Assalamu alaikum everyone. I hope you all are fine. In this video we will do factors. Let's start. Before starting new factor or studying factors in detail, we will do this question from exercise 2b on page 28. Which of the following are co-prime numbers? So we studied co-prime numbers in our previous video. And to see co-prime numbers, we'll write factors first. So let's do the first part. 3 and 5. Which of the following are co-prime numbers? Okay, so first we will write the factors of 3 and 5. Okay, so here are the factors of 3 and 5. Factors of 3 are 1, 3 and 5 are 1, 5 because these are the only two numbers which can divide 3. And similarly, these are the two numbers only which can divide 5. So these are the factors of 3 and 5 respectively. And the numbers which have only two factors, 1 and the number itself, what do we call those numbers? Prime numbers. What do we call those numbers? Prime numbers. Okay, now let's see their common factors. Which is the common factor in both in these two numbers 3 and 5? Only 1. So they have only 1 as their common factor. They have only 1 as their common factor. So it means that 3 and 5 are co-prime numbers because the numbers which have only 1 as their common factor are called co-prime numbers. So 3 and 5 are co-prime numbers. Okay, for second question, factors are already written here. Factors of 31 are 1 and 31 only because only these two numbers can divide 31. There is not any other number which can divide 31. So 31 is also a prime number. But for 62, it has 4 factors. All these numbers can divide 62. So 62 has 4 factors. So it is not a prime number. But we have to see the co-prime numbers here. So we will see their common factors. 31 and 62 have 1 as their common factor and also 31 as their common factor. So 31 and 62 have 2 common factors. So is it a co-prime number then? No, these are not co-prime numbers because they also have 31 as their common factors. So no, 31 and 62 are not co-prime numbers. Now let's do the last part and write factors first. Okay, so now 72 has many factors. These are all factors of 72 and these are all factors of 55. So they both are not prime numbers because they have more than 2 factors. But now we have to look at their common factors. So let's see how many common factors they have. 1, because 1 is a factor of every number, each number, even factor of itself. And is there any other common factor? 5, but there is not any 5 here. 11 not, and 55 not. Okay, so they have only 1 as their common factors. It means 72 and 55 are co-prime numbers. Yes, 72 and 55 are co-prime numbers. So it was just a little revision. Now we'll start studying factors in detail. Okay, it's from your book, page 28. Yes, page 28, factors. Now, as you can see, what is happening here? Let's read first this. We can arrange objects in groups. In the table given below, 12 pebbles have been arranged in different ways. So there are 6 boxes here, and in each box 12 pebbles have been arranged in different ways. Like in the first box, pebbles have been arranged in ones. Here 12s are arranged in 2s, and here in 3s, 4s in 6, in 12s. So the 12 pebbles have been arranged in 6 ways here. What does it mean? If we can arrange 12 pebbles in ones, it means 1 can divide 12, 12 can be divided by 1. If we can arrange them in groups of 2s, then it means that 12 can be divided by 2, because 2 6 are 12. Similarly, it means 12 can be divided by 3, 12 can be divided by 4, 12 can be divided by 6, and 12 can be divided by the number itself, which is 12. So what do you understand by this? It means that 12 has 6 factors, 1, 2, 3, 4, 6 and 12. So the numbers which can divide a given number are called factors of that number. So whenever we have to see the factors of a given number, we check that which numbers can divide the given numbers. On next page, on page 29, it's explained here that the given example, the examples of pebbles, we conclude that 12 can be divided completely by 1, 2, 3, 4, 6 and 12. So in this box it is shown in detail that 12 can be divided by these 6 numbers, and divided means that completely divided, leaving zero remainder, leaving no remainder. So these 6, 1, 2, 3, 4, 6, 12 are called the factors of number 12. So now I hope that the concept of factors is clear and how to find the factors. Now we'll do exercise. Okay, first we'll do these examples. You have to find the factors of these two numbers. So let's find the factors of 15 first, then for 49. Let's do the first one. Find all factors of 15. Okay, so now let's check which numbers can divide 15. So we know that 1 is a factor of every number. It means that 1 can divide every number. So 15 divided by 1 is equal to 15, and the remainder 0. Now let's check with 2. 2 can divide 15 or not? No, 2 cannot divide 15. And for 3, yes, 3 can divide 15. 3 5s are 15. So 3 is also a factor of 15. Now let's check for 4. But 4 cannot divide 15. So we'll not write 4. 5. Yes, 5 can divide. 5 3s are 15. Now, and then 6 cannot divide, 7 cannot divide, 8 cannot divide, 9 cannot divide. So only 15 can divide 15 now, because each number is a factor of itself. So it means that 1, 3, 5 and 15 are the only numbers which can divide 15. So what are the factors of 15? 1, 3, 5 and 15. Factors of 15 are 1, 3, 5 and 15. This is a one way of checking factors, but there is also another way of seeing factor. Let's do that one also. Okay, so for this we have to find the pairs of numbers that give 15 as their product. Means the two numbers which when we multiply together give us 15. So first pair is 15 multiplied by 1. It gives us 15. Then 3 5s are 15. Is there any other pair that give us 15 as their product when we multiply them together? No. There is not any other pair, so we have only two pairs here. So now, as you can see, 1, 15, 3 and 5. So again we have four factors of 15. So now it's up to you which method you use. You can do like this, or you can check which number can divide 15, or you can see the pairs that give us 15. So we'll write factors here. 1, 3, 5 and 15 are the factors of the number 15. Now let's do this one, 49. So now let's see which pairs give us 49 as their product. First one is always this, 49 ones are 49. Then any other pair? Yes, 7 sevens are 49. Is there any other pair? No. So 49 has only one. 49 has only 1, 49 and 7 as their factors. So what are the factors of 49? 1, 7 and 49. So 49 has only 3 factors. So I hope now you know that how to find factors. If we do this question by another method, we can see which numbers can divide 49. For that, again, because 1 is a factor of each number, for 49 divided by 1 is 49. Then 49, 2 cannot divide, 3 cannot divide 49, 4 cannot divide. You can also check by divisibility rules you have done. Okay, 5 cannot, then 7. 11s are 49. And the number itself. So again only 3 numbers can divide 49. So 1, 7 and 49 are the factors of 49. Okay, now let's move to the next. Okay, so question number 2 from exercise 2C on page 30. No, question number 2 is on page 31, not 30. It's 31. Okay, so state whether the following are true or false. So you have to write it's true or. Okay, first one, 7 is a factor of 45. Is it true? 7 can divide 45. No, it cannot. 7 cannot divide 45. You can check by dividing. 7 cannot divide 45, so it's false. If a number divides another number completely, then the first number is a factor of the other number. Yes, it's true. Because the number which can divide completely, leaving remainder 0, is a factor of that given number. See part, 6 and 8 have an equal number of factors. For that, you will have to write the factors of 6 and 8 first. So let's write the factors here. What are the factors of 6? Which numbers can divide 6? I'm writing here 1, 2, 3 and 6 itself. So 6 has 4 factors. And how many factors 8 has? 1, 2, 4 and 8. So yes, 6 and 8 have an equal number of factors, so it is true. A number is always a factor of itself. Yes, it's true. These 2 points are very important, that a number is always a factor of itself and 1 is a factor of every number. Okay, the last one is 45 is a factor of 9. No, it's false. 49 How can 45 be a factor of 9? 9 is a smaller number and 45 is a bigger number. So 45 cannot divide 9. So it's not a factor of 9. It's false. Now let's do another question. Question number 5. Write yes or no. Okay, you have to just tell that if yes by yes or no. Is 12 a factor of 36? You can see by checking, by saying that 12. Okay, now yes, if you multiply 12 by 3, we get 36. So 12 can divide 36, leaving 0 remainder. So it means yes, 12 is a factor of 36. Is 7 a factor of 45? 7 cannot divide 45. 7 sevens are 49. So no, 7 cannot divide 45. So no, 7 is not a factor of 45. Is 6 a factor of 66? Yes, is it? Because 6 can divide 66. You can check the bigger numbers by dividing like this. So yes, remainder is 0. So yes, 6 can divide 66. So 6 is a factor of 66. Is 20 a factor of 100? Yes, because 25s are 100. So yes, you can see by multiplying here. If you multiply 20 with 5, then we get 100. So yes, 20 is a factor of 100. Is 16 a factor of 64? So you can check by dividing. You can check this by dividing. So 64 by 16. Okay, if you multiply 16 with 4, we get 64. So yes, 16 fours are 64 and we get 0 remainder. So yes, 16 is a factor of 64. Now let's do another question. Okay, it's question number 6 on page 31. Okay, 31 or 30. Write down the factors of these numbers. Okay, so again you have to write the factors. How many factors does each number have? So let's do the first one. 25. You have to write the factors of 21. 5. So let's see which pairs make 22 as their product. Start from 1. 125s are 25. Then 2. No, 2 cannot divide. 3. No. 4. No. 5. 5 fives are 25. So these are the only two pairs because there is not any other pair that give us 25. So how many factors does 25 have? How many factors does 25 have? 1, 25 and 5. So 25 has only 3 factors. 25 has only 3 factors. Now let's see how many factors does 32 have. Okay, first is 32. Then if you check by 2, then 2. 16s are 32. Then for 3 cannot divide 32. 4 8s are 32. 5 cannot divide. 6 cannot divide. 7 cannot divide 35. And for if we check 8 4s are, so it's already written here. So when number starts repeating, then you stop. So 32 has how many factors? Let's count. 1, 2, 4, 8, 16 and 32. So 32 has 6 factors. How many factors? 6 factors. So this is how you check factors. You can also use another method. The first one, in which we check which numbers divide, or you can use this pairs method. So it's all for today, and your homework is to do question 1 and 3 on book, and question 4 and 6 you have to practice on rough notebook. And if you have any question, then you can contact on school's contact number. Thank you. Allah Hafiz.